Hi everyone. Um, Welcome to 505. Today we will look at functions. Uh, Function is sometimes the last topic in Python in 505, or sometimes the second last. So in this semester, this will be the second last the topic in Python. So we will do one more topic next week, um, which is about object orientation. That is related with this function. Um, and then I believe we have, uh, after next week, we will have 3 more weeks before the final exam. So for the last 3 meetings, at least 2 meetings will cover networking. I think the first week purely the concept of networking, and second week hands-on exercises and a little bit of a practice, so that we can set up TCP client and server, and also UDP client and server, so that we can communicate. So that will be the topic. And then probably second last week of this semester, we will do the wrap up and review of your exam. So so that's what we are trying to do basically. Okay. So the topics, the functions start. I mean, today's lecture covers this. There are 2 kinds of functions available in Python. Not only in Python, many other languages also. When we comes to functions, then functions are given, and also function may be needed, so that we have to define. Okay. So user defined the functions is the things that we are trying to do today. Using functions, using built-in functions, we have done many times so far. For example, print, that is a function. Int, if we want to convert number like strings to real number, could be integer or floating points, then we can use int function or float function. If we want to make our program user interactive, then we make we need to first ask, right? So there is a input function, so that it can provide prompt statements. In response to the prompt statements, user can respond to it. So user's response can be taken by one of the variable that you declare, and then we work from there. That is another typical function. There are so many other functions that we learned so far. List, there's a, one of a typical function, list, and also tuple. So data in tuple can be converted to a list by calling list function and vice versa. Those are built-in functions. So we'll look at today the user-defined functions. There are two types of user-defined functions. Functions that we declare and define can be, functions can stay alone, that we will do today, okay? Standalone functions, so-called. And there may be another type of functions that we can define, but the way that we define functions is define it as an element of an object or a class. So there's object orientation. That'll be coming next week. Object orientation is the concept that you need to understand in order to make your Python code more professional. That is the first step that you need to do, okay? Object orientation. That's one thing. Another thing that the reason why you need to do object orientation is when it comes to graphical user interface codings, then everything, you don't really create something new from scratch, but you invoke some of the classes already defined. When we say class, then one of the components of the class, or one of the elements of the class is a function. We call that method in that case. So method and function looks similar, but when function is defined within a class, then called methods. So that's what we will do next week. So what we can do is two things for function related topics. We need to know how to define it and also use it, right? Once we define, then we have to use it. The way that you use, we already used it so many times so far for those built-in functions. So built-in functions already defined and provided. So only thing that you need to do is to invoke. So invocation of functions are already known. So we did that already, right? Basically, we will learn how to define, okay? So now, remember that when we invoke a built-in function, then we have to look at the libraries, so-called the API, application programming interface. So how function can be interactive to you when you invoke it. So you have to read how it is defined and in what way that function can be invoked, right? So when you define a function, then we have to also consider that. Are you going to receive anything from that invocation? Are you going to return back to the caller? Those things needs to be considered. So first, the defining functions. So when you define functions, it looks like def and func. Func is a name, and open parenthesis and close parenthesis. When you see on this box, blue box, def, there is a reserved word, so-called. It is for define. So define a function. This is your function name, followed by open and close parenthesis. If you want to receive any data from the caller, when it comes to invoke, then you need to specify that what you want to receive within this parenthesis. And then you have to return it. Okay? So when you return, then it is given to, it is passed to the caller. Okay? So for example, if our input is a variable of a and b, then your function is a and b. Those two variables needs to be specified. This is a func, open and close parenthesis, with the variables that you want to receive from invocation. And then ending with the colon. When it comes to colon, then there will be the function body. You need to do some of the computation with the variable a and b. So could be one or more lines of codings. And then if we want to return, then this function should end with return. Okay, whatever you want to return. Okay, the value C. So value C will be returned. That will be the output of this function. So this function has input A and B, output C. Once you define a function, then what is the beauty of function definitions? One time defines and multiple invocation. You can invoke multiple times. But there is a thing that you have to keep in mind is, in order to call this function, you need to pass two variables, a and b, actually two values, right? Then this function receives those two values and computes. And whatever the result and whatever this function wants to return, that will be C. So C will be returned. That will be the output of this function invocations. These invocations can be done multiple times, not only one time, but multiple times. So this is a called box. This is a caller box. So caller call the functions, and this called function returns two caller statements. I want you to recall some of the mathematical formula, equation. Okay, so it could be some of the computation. 3 squares plus 2 times 3 minus 5, or some other times 2 squares plus 2 times 2 minus 5, sometimes 5 squares plus 2 times 5 minus 5, or sometimes negative 2 squares plus 2 times negative 2 minus 5. All of those equations can be written in this way, right? F sub square plus 2 times x minus 5. So x, whatever x that we call, if x given 3, then it'll be 3 squares plus 2 times 3 minus 5. If x becomes 2, then it'll be like this. So depending upon the x, there'll be different equation to compute. And we call this function of x. Function of x. So see, this is defined. This is the definition of a function of x. The way they would invoke this function is, we call this f sub x. So within this parenthesis, this guy waits to receive x. So we say, how about number 3? How about number 2? How about negative number 2? So we can send those numbers to this function. This is the body of that function. This is a signature, f sub x. For example, f sub x, this is a signature. Body inside here, that'll be this. That is, some of the statements needs to be listed there in that coding list. Okay. So this is a function definition. This is a function invocation. We call this caller function. We call this called functions. Once a function is defined in this way, then we can invoke it in this way. F sub 3, then it goes there. This function signature receives x, and in the body of that function definition, there's a computation, x times x plus 2 times x minus 5, and whatever the computation result. If it is returned, that is returned. So this is when this function evaluated and received the returned value. That returned value is the outcome of right-hand side evaluation. Remember that if we have equal sign, then right-hand side should be evaluated. The outcome of this evaluation, which is the returning value from this function definition, assigned to y. Okay. So defining has two things, a signature and body. Signature has input arguments and output. So inside of the body, we don't really need to know. Most of the built-in function, we know the signature. What is the input? What is the output? We don't really, they don't really show to us the body, and we don't really we don't really need to know the body of that function definition implementation, right? It can be implemented in one way or the other way. So body is all the implementation details. But from the function definition, what we really need to know is the signature, input and output. Okay? So when we invoke, then we need to pass the variables or value to the variables to the function. Okay? And if you want to do further work by receiving the result of that function invocation, then we receive the output, and then we can do further. So, for example, if we want to convert a Fahrenheit temperature to Celsius, then this is the formula. Given Fahrenheit temperature, and then we subtract it by 32, and then multiply by 5 over 9. So that is a computation. This is something that we know, right? In our coding, then we need to say in our function that is a signature, and this is let's say this is the body. In the body, there is a computation. So f is the input, and then this computation, and assigned to C, and in this function definition, C will be returned, right? So this computation started by receiving f. So f is applied to this right hand side evaluation, and the outcome of this computation will be assigned to new variable c. So c will be returned. So in real code, it'll be like this. So input, u input, we call the built-in function input. And this built-in function receives the prompt statement. So we send this value. Enter temperature in F, colon, \n. So your cursor will wait after the new line. So carriage return will move to the next line, and then the cursor will be blinking in the next line. Okay. And then this is a temperature. The input receives user entered character in string. So that string needs to be let's see here. No. I want to see if there is any. Okay, so this will be converted to int. Remember that int, this is a built-in function. This built-in function takes number-like string to convert to an integer. So evaluation of this function call, outcome of this is returned to, is assigned to new variable f. Okay. And then there's a computation. Because we have an f, according to this formula, c is obtained, and then we can say print f in Fahrenheit. Some temperature in Fahrenheit will be another number in Celsius. That's what it is. So this is a defining function, definition of the functions. Okay, and this is call within this print statements. If this is the function called the convert to C, that function with the function name, open and close parentheses, and whatever the variables, whatever the value that we call, entire this is the invocation. This is the invocation statements. The real function definition is here. So stopping this, so we'll practice it here. Functions, there are two types of functions, right? Built-in functions and user-defined functions. And user-defined functions can be defined in standalone, or can be defined in a class in object orientation. All right, so we will do, as an example, conversion of Fahrenheit to Celsius in temperature. So we have to first define, right? Define function. Once we define, then we need to invoke the function. The way that we defined is this: def, and then convert to Celsius. We'll receive the Fahrenheit, F, and then our compute is this. We want to given F, we subtracted 32 and times 5 divided by 9, and that is assigned to C, and then we return C. That is a function definition. The way that we invoke, then we need to get the data from user. So user input equals input, and then we can say enter number in F, and then so backslash n, then cursor will wait for you on the next line. And then that Fahrenheit, because it is in string so far, so we need to convert it to integer. So you input the number like string needs to be converted to integer and assigned to F. And with that F, then we need to call. So we need to call, when we call, we need to use this function name. So convert to C, and if we see this function, then this guy the waits 1F, right? So we send this F. Here this guy says F and Celsius. Here, if we do not want to do this, then you can do temperature in Fahrenheit. So temperature in Fahrenheit, that'll be fine, right? And then we can save this. Save this. Okay, mercy. Func homework, I think it'll be, I don't know, homework 4 or 5. What is the homework? Oh, 4. So another homework will come here. So that'll be 5. What happened? This is home. cursor is not. Okay, I want to redo. Okay. Why this guy wants to see my where am I? Save. I think there is some issue. So let's move further. Don't save this yet. Okay, then we need to run this. Okay, this guy says my cursor is not moving. What happened? This is okay. Okay, let's see. Oh, 55. Cursor is not shown, but 55 and hit enter. Then this convert to C, this is written. But if you want to make it more nice in pretty format, then you need to do print, and then given function in Fahrenheit is in another number in Celsius, and then we can say format, and the first number will be simply F, and second number is the outcome of this function call. Okay, I think that is it. So if we call it, then it'll be, say, right now the temperature in New York, let's see, yeah, 52 Fahrenheit. So I would say 52, enter. F is not defined. Yeah, of course, this we call that TF, so it should be TF. Then we can my cursor comes up here. So we can call 52, hit enter. Then 52 in Fahrenheit is 11 in C. What is this? Okay. If you want to make this, if you want to the value of the iterative floating points, then you can say if you want to receive only second place in decimal points in that floating points, then you need to say pointer to F, and then 52, then it'll be 11.11. Pointer to means 2 decimal points in Fahrenheit. If you want to change it to 3 numbers, then it'll be here and 53, then 11, 6 to 6 to 7, something like this. Okay. So basically, this is a function definition, and this itself is a function call. This is a function call. Only this is a function call. All others, some other things that we do for this function invocation. Okay, this function call can be done separately in the coding line, or it could be within this long list of the coding statements. That'll be fine, as we look at here. Okay. What else? Another thing that we could do is remember that the reason that we need to do function define is to make it available so that multiple times of invocation can be served. Okay, for example, convert a numeric grade to a letter grade. That is something that we usually do. Then we can, I want to copy this. See if I can copy it. Oh, good. So I can copy it. So define the grading. We receive this PTS is a numeric grade. Given the numeric grade, if it is greater than 55, that's what we have, then letter grade will be a, if it is greater than 59, any number greater than 59, that will be A. If it is not the case, including 95, I think including 95, right, including 95. Anything below 95, then we need to consider in the next case here. In this case, the very next if statements is with this condition. If point is greater than or equal to 90, anything less than 95, then we consider here in this highlighted coding block. But first condition that we want to consider is if it is even greater than 90, greater than or equal to 90, then the letter grade will be A minus. Okay, so any number between 95 and 90, then that is A minus. We continue to do anything, if other than this, anything that we consider here, other than this, then that will be not anymore 95 greater than 95, but not anymore greater than 90. So below 90. So the very next if condition is to compare with the 85 or 84 greater than 85 or equal to. Then that will be B plus. Same thing. The next step that we want to consider is how about below 95 but greater than 80. Below 80 but greater than 75 or equal to. Below 75 but greater than or equal to 70. And we go further and further. Okay? So that is, so you need to compare this. This is a conditional statements. By having this, we need to make sure all these numbers are considered. Anything greater than 95 are considered. Here, anything greater than 65 are considered. other than over 65, anything below 65, then that'll be F. So we will have L grade in any conditions here. And finally, we will return L grade. And that L grade will be now considered here. So we can say student has, for example, Adam, no, we don't need to. Anything, for example, any number, 77, 89, 92, 95, 69, 85, 84, those numbers. So we want to print say 77 in numeric is the grade, whatever that is. Okay, that can be done by formats, and then we can say each of those number we need to say, and that number needs to be passed to that grading function when we invoke that grading. So grading function is written here. What we want to do here, for this statement, student list, for each student in student, what we want to do is, now we want to do that students, that number, right? So we have E student, that student number, each one at a time, each of these numbers in this list. Remember, this is a list. So for loop, with the list can iterate each element in the list. So first number that we have here for ESTU, that'll be 77. Next number is 89, and so on and so forth. And this is the number. So that number needs to be passed to this function PTS. So we need to pass this number ESTU. Then this function can be evaluated, and therefore we can receive from this function call the grade, whatever the grade. That grade will be plugged into this placeholder. So this first placeholder will be each of this number. Accordingly, there will be a converted letter grade comes here. Okay, automatically. So there is no user interaction. So if we call that very quickly, 77 in numeric is the grade C+. 77 is a C+, right? When we come here 77 is not greater than 95, so go next. The 77 is not greater than or equal to 90, goes next if, else if greater than 85, of course it is not, so skip to next. And then the 77 is greater than or equal to 80, no, so go next. 77 is greater than or equal to 75. Yes, it is, because it is in between these two numbers, right? So that'll be C plus. So it is a C plus. Nice, right? So whichever the great things can be done here. This function can be invoked how many times? 1, 2, 3, 4, 5, 6, 7. 7 times. That'll be great, right? So we can do in another way. If we have students in dictionaries, then we can have this, for example, copy and paste here, and then we can say Adam as number 77 and Chris number is 89, Peter number is 92, David number is 95, Brown number is 60. We'll skip here, right? So how can we do similar to this? Then we need to do for loop for each student E in stud dictionary, and then we need to copy this, and we need to change this. We need to put here a number. So for this number, what we need to do is that can be done is studict with the key. Remember, the dictionary is key and value pair, and values can be assigned by key. So for each in the dictionary, then this each will be the key from this dictionary. If it is a list, then like this, for list can be accessed by index. So for index number in the list, so list, this for each means in this case a number starting from 0, because list can be accessed by index. Index counts from 0. So 0, 1, 2, 3, 4 here. Here, Adam, Chris, Peter, not necessarily in this order, but it consider each of these key in the dictionary. So this is this number 77. So this number needs to be passed to this function. So this function receives that number as PTS. So we need to send that. This is the number. Given key to this dictionary, then we will receive the number. That's what it is. So if we invoke this, we need to change this. So each students, so we'll have here, no, we don't need to do it. We need to say student E, key. So Adam earns grade, whatever that is. We want to say that, okay? Adam wants grade what? Chris earns grade what? That's what we want to do. So we'll write the key, each of these key. So who, this is nothing but who. This is nothing but the number for who, which is E. So if we execute this, then we say here the one time this print statements and next time that print statements, right? So after this, we can say Adam wants grade C plus, Chris wants grade B plus, and so on and so forth, right? Okay. That's what we did, all of this. So class, in a class, so we don't, the function can be defined in a class. Remember, this is a class name, and element in this class is a function, so this will be the function there, but this will be done next week. Let's see, this function, class function. I think this, basically this is all we have, but I will do a little more extensions here. Let's do it in this way. Function can be defined over a data type. Okay. Here, function can be invoked by considering a data type, right? So when we invoke a function, we consider data types. One time, like here, list, and another time here, a dictionary. Okay. The last thing that we want to do today, how we can define the function over data type rather than invocation by considering data type. So define a function, let's say sales. Sell price, price include sales tax. So given item and city, then we need to define, right? Product, say if it is laptop, let's say Windows laptop, then let's say that is $1,000. And Mac laptop, then 1,800. And mouse, maybe $50. extra monitor, maybe extra keyboard. Keyboard maybe 75, and monitor maybe 200. So that is a product's price. And then we can do sales tax depending upon the city. Let's say Manhattan. Manhattan sales price is that's 10%, 0.1. And White Plains maybe 0.099%. Queens maybe 0.85. Okay, so we need to do given item, then we need to get price, right? Price can be get from the dictionary products. Given the keyword item, then we will get the price. And also we need to find out city. City is given, right? So tax rate can be get from sales tax. And then we can, if we give city, then price is, total price will be price times 1 plus tax rate, right? Then we can total. And then purchased. I purchased, purchased one will be I think that should be also dictionary. So it'll be, say, Adam purchased list of those. No. Yeah, first purchase will be the tuple from empty. This guy purchased the Windows laptop from empty. And then second element, second purchase is mouse from Queens. Let's say like this. And then we can say for user in for purchase in purchased one. In this case, only one guy, right? In this dictionary, it doesn't matter. We can add more and more if we want. And then so items to purchased can be accessed by purchased one. For that dictionary, the key is purchase. Let's make it simple. Rather than purchase, we call that purch. This guy will return the value, all of this. Okay. So we need to make another for loop for each item in items. Then each will be one element. First, this because this item is a list. Remember, this is item is a list. Items is a list. So for each means an index, because a list is accessed by an index. So this is the first index will be a tuple. Okay. So this tuple, then very nicely, then we can send item and city, right? So we can price included in text. There we need to send so each is an index. So items each, there's an index. And then first element, that is the products. So that'll be 0. And then second variable is, remember that item is a list, this whole list from here there. And we need to access first tuple and second tuple. So in the first, this is a first tuple, second tuple, and third tuple. This is items each. When it comes to this tuple, then we need to access first element in a tuple, that is the purchase item, and second element in a tuple, that will be the city. So the second one is a city, which is this. So that is the price. So we can say each price is that. So this is the function call, function invocation. The result of this function invocation is assigned to this variable. And then we can say print each price. We need to make sure if it is good or not, but we'll see whether it runs or not. So let's try to execute. All right, here, the list indices must be an integer or a slice, not a tuple. Okay. The way that we can invoke, the debug is in this way. We need to do print each we want to see what is each. Okay, each is this. Oh, each itself is that. Oh, so we don't need to this item. We simply do because each is already a tuple. And then we can say each is a tuple. So within the tuple, first element and then second element. Okay, this should work. We don't need to print that. So hit enter. Then we can say this guy purchased the Windows laptop. Price of Windows laptop is $1,000. But this guy purchased it Manhattan, so 10%. So 10% of $1,000 is 100. So total price is 1,100. That is 1,100 here, right? And then second one is mouse purchased in Queens. So price of a mouse is 50. Queens tax rate is 8.5%. So I think it is, should be 0.085. Yeah, it should be 425, 54 to 25. If you want to see how much Adam spent today, then we need to declare here temporary temp sum. Let's say that is 0. That's 0. And then this price needs to be temp sum added to this each price. Okay. And then we can do here print Adam pay this amount for your let's say here, and then format. Purchase is a person, right? Purchase is the key. Key is a person. So purchase. So each guy here, Adam, pay this amount. That is temp sum. We can say temp sum. And then we can do oh, now it works. I think this guy is working something else. In class, okay. Let's call it func homework5.py. Okay, that's saved. I want to make here another, let's say, I want to make a copy of this. So Peter purchased the MacBook from Queens, and mouse from Queens, and one more monitor from, 1 more monitor from Queens, and 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 1 more white planes. Okay. So for those two guys, see how much, what we will, and this is like billing, right? So we do here, enter, very quick. Adam, pay this amount. Peter, pay that amount. And we go this very nicely, right? So this function definition can be made over a data type. In our case, we use the dictionary, right? And then one more time, we invoke this function with the data in the dictionary, where the key and value in list. But in this value list, there is a number of tuples. Tuples, usually two elements, item and city, item and city. Okay, so this is, yeah, things that we could do. I think, yeah, this function definition and function invocation needs practice as well, right? So to help you guys practice more and more, I want to give you homework assignments so that you can do further. Okay. Homework assignments maybe, I would say, similar to this. I want to expand a little more from this. Okay. All right. Any question?
No questions so far.
Great. All right. Then I'll see you next week. Next week we will cover object orientation. That will be
Okay.
the last topic in Python coding modules. After that, we will have one more module, the last module, which is networking. As I said, networking 2 or 2.5 the sessions, 2 weeks or a little bit more. All right.
Mhm.
And after that, we will have the final exam. All
Okay.
right. I'll see you next week.
All right.
Have
Thank
a
you,
good one.
Professor.
All
See you
right.
next
See
week.
you. Bye.